Okay, so I was going to go over some recent subfiling results that I've gotten with no local storage on Summit. So as you know, Summit has NVMEs that you can access from a node, and then also has, in addition to the GPFS system that you can write to. So in order to enable writing to a node local storage in batch, all you need to do is specify this bsub command. Is anyone see my screen, by the way? Is it readable, or should I make it?
No, it looks good.
Okay. So you can either, I have a script, so I just add it to my bsub commands, this alloc NVMe. So that's all you have to do to be able to have a job access node local storage on Summit. And then to write to the node local storage, with subfiling, you just have to basically set this subfiling prefix to where the node local storage is, and on Summit it's at mount bb and then your username, whatever username that is. So when you run a job, then all your subfiling files will be on those node local storage. Just to remind you that when you have a job and you have subfiling, you will have the stub HDF5 file, which basically just contains the magic number. So if an application uses or wants to read an HDF5 file, it will find the magic number and say, yeah, this is an HDF5 file, but it doesn't have any contents. The contents of the HDF5 file are actually in the subfiles, and they're usually split up. So in this case, it was 4 subfiles. So it's 1, 2, 3, 4, and then it has a node number, inode number, unique to the run. And then you have a config file that tells what subfile names there are and other stuff. So you have these files that you have as a result of a run. Now, when you run it on a node local storage, since, for example, if you have 4 nodes and you have 1 subfile per node, so that means that node 0 will see you have 1, and it will also have the config file, because by default, the process 0 writes the config file, and that will be on node 0's local storage. And then the only thing that will be on node 2, for example, will be this file here. There's 2 out of 4. And then the only thing will be on node 3 and 4 will be the same. So they'll split up. And you cannot access a node local storage from another node. So what you have to do then, if you want to put the files back together, so we have a utility called H5 fuse that takes subfiles and puts it into an HDF5 file. So if you want to do that, I'll get to that later. But first, I guess what we did for this benchmark was we use H5 Bench, which is it's a program on GitHub available that you can just run different IO patterns. And for this, it's basically the vpic application, and we're just using studying writing for right now. And the file sizes was pretty small. I mean, it's for 21,000 ranks roughly. It's almost a terabyte, but that's pretty small. But this is the size I've used. So I looked at these number of ranks, and then I do weak scaling with the file sizes. So if we go back then, if I have all those subfiles for now, so for example, I'll have 512 for this because I do the default settings for subfilings, and that the default is 1 subfile per node. I haven't played yet with using more subfiles per node, and I haven't played with the number of servers per node. So I did set the alignment to be 16 megabytes, but which works well for GPFS. I'm not sure that's actually needed for NVMEs, so that needs to be studied. But for now, I just use the same as got good results on GPFS, which is 16 megabyte alignments, and 16 megabytes matches the 16 megabyte stripe size in subfiling itself. So as I said, once the run is complete, then you want to transfer the subfiles on the node local storage back to the parallel file system. So either you can, if you want to preserve the subfiles, you can just copy them back from after your job is done, just copy them back to the parallel file system. or what I did was use H5 fuse, which fuses the files back into a single HDF5 file from all the local nodes. The thing is, you have to, in order to access those files, you always have to run another batch, well, equivalent to an MPI exec run, which on some it's just JS run. So what you have to first do, H5 fuse needs the .config file, and that's only on node 1. So what you first have to do is copy that file back to the parallel file system so that when we run the next command, all the nodes will have access to that config file. And we've discovered that simple POSIX commands don't seem to work on the node local system. So we had to, with the help of the help desk at Oak Ridge, they came up with this command to be able to copy a file to the parallel file system. I couldn't just, for some reason, I couldn't just do a copy star config to that file. I had to do this find and then that. So it's the same with all the commands that you'll see that you have to do that. There is a new option that we just added, that Jordan added, and it'll be in 1.14.1, that you can specify an environment variable and it will place that config file then in that location. So instead you'll set that to be the parallel file system. So you'll get to avoid that, having to copy that from one of the node local storage. And I mentioned that part about the wildcards don't really work on Summit, so you have to do kind of a workaround for that. Once you do that, then I do another parallel run. And this time I specify, so I only using one thread per node. So I don't need to run them all. I just need to run how many nodes, or how many one thread per one rank per node, since all I'm doing is copying those subfiles. So that's what I specify here, and I just loop through. This is just part of the loop to do the benchmarking. So then you call the H5Q, which is just a shell script that calls DD, that copies, essentially copies that into a certain offset in the HDF5 file, which will be. And there's a few new options we've added since the 1.14.0 release of this script. So the first one, this -R, we thought it might be helpful for people if they want to remove the subfiles as they're processing them and putting them into a HDF5 file, so you don't have two copies and that could use up a lot of disk space. So if you specify -R, it will remove the files as you are fusing them into the HDF5 file. There's also an option to quiet the output that H5 fuse normally does. And then you can give it for this, you can give it a location of the config file, because it always expects, technically this is getting run on a node. So it normally expects that the config file will be available wherever you're running this script from. But this gives an option, since the script file is in the parallel file system, then you can give it option to where to find the config file. So now let's go on to the results. So this is running H5 bench. And I plot the observed write time, and this is the number of ranks. Make this a little bit bigger or smaller. Okay. So the first, this red is with no subfiling to just the GPFS. So it scales as you would expect. So it's weak scaling. So it's expected to increase as you increase the number of ranks. And then the blue here is subfiling to GPFS. So we're just writing to GPFS, and you can see it performs much better than writing it with no subfiling. And it's a little bit better here than it was. I mean, it's order of magnitude better for writing to GPFS using subfiling. Then the green is now using subfiling to local load storage, and basically they're the same. But you see, do see an advantage. So this is running at, each case was run 5 times. And so this is the mean, it's the bar, on the typical whisker plots. And these are outliners from the mean. And so you can see that even with using DD or writing to no local storage is still much faster than going to GPFS. Now, if you want to then fuse that, I timed just the 21,000 ranks case. And so the blue is fusing it from a GPFS. So you're on GPFS, all the files are on GPFS, and you're just fusing it into an HDF5 file. And that took about 50 seconds. So even if you consider the time to write that, which is 60 seconds plus another, so you're still below what it would have taken to write to GPFS. So it's still a win for writing it with subfiling to GPFS. Now, if you were to do H5 fuse from the no local storage to the GPFS, this is this line here, and it was very fast to do it that way. So even then, it's at the total, I think it was roughly 6 seconds to do it, compared to that's with writing it all and then fusing it back to an HDF5 file onto the GPFS file system. So it's 6 seconds compared to 100 and some seconds with no subfiling. So that's all I have right now. So we plan to do more studies on Summit, particularly at probably at the largest one with this 50,000 ranks. And then we also plan to study the effects of the number of subfiles on a no local storage to see if there's any improvement by using more, have some more subfiles per local load. So is there any questions about that? We're pretty happy with this result. It scales very well. I mean, per week scaling, this is very good results. I have to also check. This is with independent, which if I remember right, was better than collective, but I need to make sure that that's actually still the case on Summit at the larger scales. So I need to run subfiling on GPFS with collective and see if that's still, I'm pretty sure this was the best case though, that we could do with no subfiling.
Is there any support? Could you tie that into stage in and stage out? Well, in this case, stage out. I don't know. Is this Sloan presumably, or what kind of?
You would have to do this. You could do the same thing. You would copy your well, let me see. I mean, you wouldn't want to copy your HDF. If you have a single HDF5 file that you want to read from, I guess you'd have to, I mean, to stage it in to no local storage, you'd have to copy it to all the nodes, which would probably be a waste. But if you had if they were already broken into subfiles, then you could just copy each subfile to the no local storage and then read it in from there. That would be, you could pre-stage it in that sense.
So H5 diffuse. So to take big file and split it.
Yeah, we don't have that utility.
Oh.
I guess we could do that. You could, there's no reason why you couldn't split a file.
Right.
Yeah.
Okay. And that will be
a good utility to do that. Because you have all the information how the offsets should be.
Right.
As long as they match. Yeah. That's an option.
Scott, and this report will be on website or?
Yeah.
Okay.
It's probably going to be it's for one of the milestones. So whenever that's done, I just kind of typed it up. It's not. just so I could present it. And so,
Mhm.
but yeah, it'll be available. And we're still working on some issues. For some reason, it wouldn't, for no local storage, it wasn't able to read it back. So, because H5 bench can both write and read, and I wasn't able to get the reading to work. So Jordan's looking into that. For no local, I mean, GPFS, it worked fine. For no local storage, this is kind of the first time that we've exercised it with no local. So that's what we kind of discovered. Well, yeah, you need the config file, and that, you know, it'd be helpful to have where to place that, which we weren't thinking no local storage when we first wrote that. And I also wrote H5 fuse so you could run it in parallel. So if you have your files and you just, so if you're on GPFS and this was actually run, it can run that script in parallel. So, but in order to do that, you have to call another MPI program to get so if you're running a script in parallel, you have to somehow get your process ID. So it's a little bit more complicated, but you can run H5 fuse in parallel.
Oh, but we have
all the access.
do you remember we have this new tool that Richard wrote? I forgot what it's called, to spawn in parallel.
To run a script in parallel?
Actually, any tool in parallel. I will find the name. It was released, so it should be among the tools.
Yeah, because all I did was I wrote an MPI program. I mean, all it does is just get the process ID and then writes it to the screen. And then I get that from the script to know which process is writing. So I can split up the work. He probably did, I mean, there's no other way to do it, I don't think. He probably did the same thing.
I think it's H5D walk.
DWalk, right.
Mhm.
Right.
Okay, I'll look at that.
It may not, we need to think. But it may be, because it does all this parallelism for you. It may need some parameters probably. I forgot now. It was quite some time. Thank you, Larry.
Mhm. And sort of just out of curiosity, which sort of VFDs are part of the sort of subfiling stack? Is this eventually going to POSIX? Is there any MPI IO here, or?
No, it uses POSIX. It's all
Oh, that's
POSIX.
it. So which means we could technically also use this with Hermes, for example, with the Hermes VFD. And that would be interesting because then you would be writing these subfiles to the hierarchy, which could include a burst buffer or an NVMe or something like that. And that's interesting.
But is it stackable? Can you use stackable with subfiling?
Theoretically, you should be able to use stackable VFDs, but we haven't tried it.
Right.
But I mean, isn't the subfiling VFD itself is non-terminal, right?
It's a terminal. I mean, it writes the files through POSIX. It doesn't go back to the MPIO driver, right?
Right. But I mean, since it in turn calls the POSIX VFD, it's not terminal. It's the POSIX VFD that's.
I don't know if it's calling. I have to ask Jordan. I don't think it is calling the POSIX. I think it's. I thought it was writing its own. It uses its own subroutines. I thought.
Right. It uses its own driver. There are two drivers. One is subfiling that splits, and another one that writes. But
right.
it's not sec2.
No, it doesn't go back to the sec2 driver.
Right. It has two drivers.
Okay. Yeah, that would be an interesting thing to explore. Because it's in a way, not quite, but a parallel version of the multi or the family. I forgot what we call it these days.
A
split file driver or multi?
Split, yeah. And since Quincy is here, question probably for him. I thought that split file wrote with the MPI IO. Quincy, do you remember? or it never did. No.
Maybe he stepped away.
Yeah, because the whole point was of creating split driver to use MPIO, to do big IO with MPIO and metadata with some other driver, with Sec2. But I couldn't find anything, so I may be mistaken. Maybe it was the wish, but we never implemented it. It's still, I found all slides from Red ASCII Red, and it was performing better. Split driver without MPIO was performing better than MPIO, that system with GPFS. Maybe it's good to repeat that experiment.
Is there any other questions in general? I guess we can open up to that. I guess that's it.